Hey students, here's another example of mathematics in the real world. As we were talking about over the last several days, we were talking about slope on our coordinate plane and we determined that it was the change in y over the change in x, or the change in height over the change in distance, rise over run. So where would you see this in the real world? Well, there's quite a few places, and just looking at one of them here right now, everybody's roof has some type of a pitch to it, or slope. That's in the construction trades, it's referred to as pitch most of the time. They typically refer to it in terms of over 12 inches. When you hear a roofer talk about the pitch of a roof, or a builder, they'll talk about it being a 312, a 512, a 912 or 1212 pitched roof. Well, as that top number becomes larger, the steepness of the roof gets a little higher. Well, this one's an average, an average roof. Right here, the easiest way we can tell exactly what the pitch or the slope of this particular roof is we use two simple tools, a carpenter's square. This particular carpenter's square, the longer edge of it here is exactly 24 inches. So we take our carpenter's square, we lay it on the roof along the edge here. We want to find out, we got to lay this down parallel to the ground, so we want to find the level point, so we just take a simple level, put that level right in the center on plumb, and I know it's a little hard for you to read in that there, but if we go down through here, we can look, and it's exactly 10 inches in height. So in this particular roof we have 10 inches tall, over 24 inches in distance. Well, like I said, now we were talking about it has to be in terms of 12 inches is what everybody refers to. So what do we have to go back to? Reducing fractions, or in this case, manipulating fractions to make that denominator be a 12. So what do we need to do to change that 24 inches to 12? Well, we have to divide that by 2, right? So if we divide the denominator by 2, we also have to divide the numerator by 2. So 10 was our measurement. So if we divide it by 2, it gives us 5. So 5/12 is the pitch of this particular roof. Now, there's lots of other examples in the construction world with slope. So we'll come down off these ladders here in just a minute, and I'll show you a few other examples. Once again, here's another example of a different type of roof and a different type of pitch or slope. If you look at the edge, the roof line of this particular house, you can see that it's a bit steeper than the other one that we were on. The other one was about a 512 pitched roof. Now, just using our powers of estimation here, and the fact that Mr. Huber's been doing this a while, we can see that this is approximately about a 912 or maybe even a 1012 pitched roof. Right here, which basically means, once again, that for every 12 inches of distance that you go across, it's going to rise 9 inches. Now, other things that you can use slope for, and what road engineers use slope for, is if you look down a big hill down here, you can use our slope points if we know our distances, how tall we have to rise over the distance that we have to go down. We can figure out, what type of slope that we have, and helps to figure out the amount of materials that we may need and the like. The same on the roofs. Also, if you see a set of steps on the back of a deck or anything else, slope ties right in with the construction trades every single day. That and one of our next lessons with the Pythagorean theorem. So it leads right into that with the good old a squared plus b squared equals c squared. And we'll talk about that all next week. Thanks a lot. See you later. Bye.